Hello everyone, welcome to today's lesson in complex numbers. Although the term might sound intimidating at first, I assure you that understanding complex numbers is manageable and very useful in many fields such as physics, engineering, and fractal geometry. Today, we will go through what complex numbers are, how to visualize them, and how to perform basic operations with them. Now, what are the complex numbers? So, a complex numbers is a number that combines a real part and an imaginary part. It is written in the form a plus bi, where a is the real part, b is the imaginary part, and I is the imaginary unit, which is defined as the square root of -1. An important property of I is that I squared equals -1. This helps us work with the square roots of negative numbers. We can think of complex numbers as points in a plane, called the complex plane. The horizontal axis, called the real axis, shows the real part A, and the vertical axis, called the imaginary axis, shows the imaginary part B. The point A plus BI is plotted at the coordinates A and B. Square roots of negative numbers. When dealing with the square root of negative numbers, we use the definition that the square root of negative a, where a is positive, equals square root of a times I. For example, the square root of -9 is 3i because the square root of 9 is 3 and we multiply it by I. Equality of complex numbers. Two complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal. Operations with complex numbers. Let us now look at how to perform basic operations. So here in the addition of complex numbers, to add two complex numbers, add their real parts together and their imaginary parts together. In subtraction of complex numbers, to subtract the real parts and the imaginary parts separately. In multiplication of complex numbers, to multiply two complex numbers, expand like binomials and remember that I squared equals -1. So here in the division of complex numbers, to divide, multiply numerator and denominator with the conjugate of the denominator. Alright, now let's go through some examples to clarify these operations. So here in example 1, find the square root of -9. Since the square root of -a equals square root of a multiplied by I, and the square root of 9 is 3, the square root of -9 is 3i. Now let's have the example 2. Add 5 minus 4i and -2 plus 6i. Add the real parts first. 5 plus -2 equals 3. And then add the imaginary parts. -4 plus 6 equals 2. So the sum is 3 plus 2i. Alright, now we have example 3. Multiply 2 minus 7i and 2 plus 7i. Using the distributive property, 2 times 2 plus 2 times 7i plus -7i times 2 plus -7i times 7i equals 4 plus 14i minus 14i minus 49i squared. Then 14i and -14i cancel out, leaving us 4 minus 49i squared. Since I squared equals -1, this becomes 4 minus 49 multiplied by -1 equals 4 plus 49 equals 53. So our final answer here is 53. Alright, now we have example 4. Divide 3 plus 2i by 2 minus I. Multiply numerator and denominator by the conjugate of the denominator, which is 2 plus I. So the numerator 3 plus 2I times 2 plus I equals 6 plus 3I plus 4I plus 2I squared, and equals 6 plus 7I plus 2 minus negative 1, since I squared is equal to negative 1. And now we have 6 plus 7I minus 2 equals 4 plus 7I. In denominator, 2 minus I times 2I equals 4 plus 2I minus 2I minus I squared. This time, 2I minus 2I cancel out, and I squared now becomes negative 1 because I squared is negative 1. Now we are left with 4 minus negative 1. So we have 4 plus 1 equals 5. Now let's combine the 4 plus 7I from the numerator and 5 from the denominator. Thus, the division result is 4 plus 7I over 5. Today we've learned what complex numbers are, how to visualize them, and how to perform basic operations such as addition, subtraction, multiplication, and division. With practice, working with complex numbers will become more intuitive. Keep practicing these operations with different examples to strengthen your understanding. Thank you for following along. If you have questions, feel free to review this lesson or ask for clarification. Keep up the good work in your studies.